This is chapter 18, example 5. And so what we have here is a circuit, 3 inputs, and 3 5-bit inputs. They're unsigned binary. And what it's going to do is sort these 3 inputs, and or not so much sort them, but it's going to find which input has the largest value. And so let's go ahead and put those down. So this is the interface. 3 5-bit inputs, and of course a 5-bit output. Call that done for the top level. And so what we need to do in this circuit is make some comparisons and make some choices. So the idea, many ways to do this. I think the approach I'm going to take is I'm going to compare A and B and pass the largest value along, and then I'm going to compare the greater value of A and B. I'm going to compare that with C and pass that largest value along. So what I'm going to need to do in this is have a bunch of comparators and muxes. And so this is not a trivial problem. And when I look at these problems, I don't really exactly know how to do these. I do my very best to grind through them and arrive at the answer. Sometimes I don't. And you might see that. Certainly, admittedly, sometimes I work through these problems and blow it completely, so I just throw the whole video out and start over. But this problem, I'm just going to grind through it step by step. I don't really know where I'm going, but I know where it needs to be. So let's see what happens. The point being is that I encourage people, even if you don't know what you're doing, just do something and look at it. If it's wrong, change it. If it's right, keep going. So this circuit here, first thing it's going to do is compare, we'll say A and B. It's going to pass along either A or B to the next part of the circuit. It's going to choose either A or B to be passed along under the control of something, but the thing that's going to control that is some status signal coming from the comparator. I'm still not sure which one it is, but it's a good start. What I'm interested in is greater than or equal to. Now, I could put an AND gate in there and the greater than or equal to signals, but I'm not. I'm just going to use the less than signal. I know I can make this work. What this is saying is if A is less than B, then I want to output B. Okay, so that means B is connected here. A is less than B, I'm outputting B. So if A is less than B, I'm outputting B. If A is not less than B, it outputs A. But once again, I could have used an AND gate and ANDed the EQ and GT, but I decided to use this circuit because it saved a gate. And so let's go ahead and finish this up a little bit. And that is part of my circuit right there. I know I need to play the exact same trick, the exact same circuit with this result here, which is 5 bits, and C. And so I'm going to use this as a guide, just essentially steal that circuit here. There's my comparator. It's comparing this to C, and it's choosing one of these, the output. And so this one is 5-bit. I think we named it large, running out of room there. And what's going to control this is the same. We'll do the same trick on this thing. Yeah, I didn't get that. I certainly didn't get that right. Okay. There's a mistake. I'm going to leave that in there because, hey, I make mistakes and I find them and I fix them. So what this is going to choose, this mux is going to choose between is either that intermediate result there or C. Okay, and so the idea here is I'm gonna take another guess on this as for the muxes, and I'm hoping that's right. So if A is less than this B value, which is C, I certainly want to output C, and which is what I have this circuit set up to do. I didn't really guess at this mux here. I just kind of copied this one and it turned out to be true. So this circuit is going to work as is. An issue here is how this is controlled. I see 2 muxes in here with control inputs. Control inputs are connected to internal signals, namely the status output of the comparators. So this circuit has internal control.